So what we're talking about is we're talking about solutions, and you guys may or may not make like drink mixes at home, Gatorade, some of that like Country Time lemonade. Anything that you are dissolving something into something else is a solution. And so I need to make sure that we understand what these 5 words mean. So I'm going to start with Dylan. Dylan, do you have any knowledge of any of these words here that you wouldn't mind at least sharing? And if you don't, it's okay.
Um, isn't solvent the thing that like dissolves?
Okay, so there's we have to be really careful with our words. So the solute and the solvent, these guys go together. All right. And so let's use an example here. Dylan, you're familiar with like Gatorade drink mix, right?
Yes.
Okay, so you take the drink mix, which is a powder, and you dissolve it into some water. The drink mix itself, is that the solute or the solvent?
Oh, it's a solute.
Yeah. So the solute is what gets dissolved in. All right, so this would be the example is the drink mix powder. Drink mix powder. If you drink like a coffee or anything like that, you usually put some sugar in it. So the sugar would be the solute. It's whatever you put in to dissolve it. So if that's what the solute is, Dylan, then what's the solvent in our Gatorade water example?
No water.
Yep, exactly. So the solvent is usually it doesn't have to always be a liquid, but most of the solutions that we deal with in a normal first year chemistry class are liquids. So the solvent is the liquid into which the solute dissolves. So in the example of the Gatorade mix is the solute, the water that you're dissolving into is the solvent. So Dylan, thanks a lot. Stella, I'm going to come over to you and I'm going to ask you if you can kind of walk us through, and if you don't know, it's okay.
No, it's okay.
Anything with
Anything with
unsaturated,
unsaturated.
ooh, I got an echo.
Ooh, I got an echo.
Unsaturated, saturated, or supersaturated?
Yeah, so unsaturated means you can keep putting in like um more like stuff into the solution.
Okay, let me write
Um
that down real quick. So it is able to accept
To accept.
more, and let's use the fancy word here. It's able to accept more solute or solvent, Stella.
um solute.
Solute, yeah, these 2 words are easy to mix up, so that's why I want to emphasize it a little bit. So a saturated substance, excuse me, an unsaturated solution is anything that you're able to dissolve more solute in. And you've maybe made a drink mix where you put a little bit of powder in and you like tasted it and it tasted like basically just dirty water. Well, you didn't have enough of the drink mix in. You didn't have enough solute in. So you probably put more solute in because what you'd created was an unsaturated solution. There was room for more solute. Now, Stella, I'm
Now,
going to come back to
Stella,
you.
I'll come back to you.
Is there a limit
Is there
to
a
how
limit
much you
to
can
how?
dissolve in? Sorry about the sound.
Um, yeah.
Yeah, you can't just keep pouring and keep pouring and keep pouring because at some point it doesn't dissolve into the water anymore. You end up with that like sludge at the bottom of your cup. So once you've reached the maximum amount of solute, is that saturated or super saturated there, Stella?
Um it's just saturated.
Yep. Saturated has all of the solute that the solution can contain. All the solute the solution can contain. There's no more room. When you are saturated, it is completely full. Think about a sponge, and you can sort of absorb water, absorb water, absorb water until you get to a point where the sponge is completely saturated with water, can't absorb anymore. Now, supersaturated is the weird one, and I just have to walk you through it, okay? Let's imagine that you have, and I think Stella, give me a heads up. You see my little red glass with water next to my face?
Yeah.
Okay, so it's filled with water. So let's say that I put in just enough sugar to make it saturated. Like if I put any more sugar in, it's not going to dissolve. It's just going to go straight to the bottom because it just won't dissolve in anymore. So here's how you make a super saturated solution, guys. You're going to take that saturated solution, all right, and you're going to cool it down. And you're going to cool it down sort of slowly and carefully with no disturbances. And I'll post some cool videos of some super saturated solutions tomorrow. And what you do is you cool it down. And what that does is it makes, generally speaking, the solubility, it decreases as things get colder. So as you cool down the solution, you actually have less and less room for solute. So the solute wants to fall out. It wants to become, again, a solid. It wants to collect in the bottom of the container. But if you do it slowly and carefully enough, it'll actually stay dissolved in. So you look at the liquid and you'd be like, okay, it looks like it's just a liquid. But if you touch it, if you drop a crystal of whatever material it is, then all of a sudden there's this rapid transformation and you see all of that extra solute come right out of the solution. And it's really bizarre. It's crazy to look at, and you'll see some cool videos. So super saturated, right, is a very specific type of solution, right? It's generally heated and it's saturated at a given temperature. Then it is cooled carefully and slowly so that more solute is dissolved than should be. And this is one that we don't usually have a lot of sort of ordinary everyday experience with because they're just strange, all right? And so as long as we have these words, though, we're going to be able to tackle the meat of today's work, which is what we call a solubility chart. So I'll leave this here for a second. Dylan and Stella, any questions before we jump into this last little bit?
Yeah.
Yeah.
So since you know how it says like it's heated and then you can put like more solute in like the glass or whatever,
Mhm.
does that always apply? Like
For
if it's heated?
Yeah, Stella, great question. For virtually, I won't say everything, but for a lot of liquid solvents and solid solutes, as you heat things up, what you're doing is you're creating more motion and there's
Mhm.
more sort of, and this is a very oversimplified version of it, but you've in essence got more ability to sort of slide those solute particles in between the moving particles of the solvent. So as temperature goes up, and you'll see this in just a second on this chart that I'm getting ready to show you, as temperature goes up, you actually usually see an increase in solubility. And so this is actually a good segue into what we want to talk about next. This is what we call a solubility chart. And you have an assignment posted today that has a different one of these. But I just want to run through this with you guys so that you can understand how to read these things. So on the x-axis is temperature, right? And on the y-axis is literally solubility. Now you have to read it really carefully. It says this is the number of grams of salt that you could dissolve into 100 grams of water. So let's just pick one of these and sort of understand what this is saying. So if the salt that I'm talking about is sodium nitrate, NaNO3, this particular line right up here is telling me that if I wanted to dissolve NaNO3 into 100 grams of water, so the 100 grams of water would be the solvent, the NaNO3 would be the solute. As the water's temperature increases from 0 all the way up to about 34 degrees, right? What are we noticing about the amount of NaNO3 that I should be able to dissolve in here, Dylan? Is the amount of NaNO3 increasing or decreasing as the temperature goes up?
Increasing.
It's increasing. And that gets back to Stella's question about, as you heat things up, do you generally get to dissolve more things in? And you see how all these graphs tend to trend upward. There's one noticeable example where the trend is downward. And we'll talk more about that later on in this unit. So we can answer all kinds of questions here, right? I could ask you, hey, if I have 100 grams of water and it's at 10 degrees Celsius, what's the maximum amount of sodium nitrate that I could dissolve in? Well, I'd look at my graph and I'd say I can dissolve in 80 grams of NaNO3 because at 10 degrees for 100 grams of water, that's what the graph is telling me. All right. So now let me ask you guys a question. I'm going to go over there to Stella. Stella, what if I had 100 grams of water at 20 degrees Celsius? How many grams of NaNO3 should I expect to be able to dissolve in at 20 degrees Celsius?
At 20 degrees Celsius.
Yeah, what does that point look to be about?
Like 88, 87.
Yeah, 87 or 88. So that would tell me that I would be able to dissolve in 87 or 88 grams of NaNO3. So I'm going to write this down. So I can expect about 88 grams of NaNO3 per 100 grams of water. So Stella, I'm going to stick with you here. What if I dissolved in only 70 grams of NaNO3? Would that be an unsaturated, a saturated, or a supersaturated solution?
Unsaturated.
Yeah, because I could go all the way up to 80, but if I only had 70 something, there's still more room, okay? So this is how we kind of read this, all right? Now, what I thought would be kind of a reasonable thing to do here is to look at a couple of questions and see if we can come up with answers together. And then I think that's going to take care of us for the day. All right, so I've got some questions printed out here, and it's all referring to this chart that we were just looking at, right? And so let's start with 3A, and it says, how many grams of NaNO3 will dissolve in 100 grams of water at 10 degrees Celsius? So let's kind of go through this together. So I've got my NaNO3, and I think I already did this one. I'm at 10 degrees Celsius. And so Dylan, what kind of answer would we expect? How much should we be able to dissolve in here?
Like 80.
Yep, totally right. All right. And if at any point you're not quite sure about that number there, Stella, you chime in, Dilla, do the same thing. And then Stella, how many grams should we be able to dissolve in at 34 degrees Celsius? So here we are at 34. You go all the way up to NaNO3. What do you think is a good answer, Stella?
100.
That's absolutely right. Okay. Now I'm going to change this next question here. How many grams of KCl will dissolve in, let's go ahead and do 100 grams of water just to make our life easier. So how many grams of KCl are going to go into 100 grams of water at 50 degrees Celsius? And either one of you can chime in with an answer when you think you've got it.
Like 41.
40 something is what I heard?
Yeah.
Okay. Dylan, do you agree with that?
Yeah.
Something maybe about 42 grams, something like that. Okay. All right. Now, we start getting a little bit of a harder question here, and this gets at the assignment that I posted. So let's look at this, and then we're going to be wrapped up. So I've got 58 grams of K2Cr2O7. So I find my K2Cr2O7 curve. So I've got 58 grams that's added to 100 grams of water. Now I'm all the way down here at 0 degrees Celsius. So I want you to think about this for a second, Dylan. At 0 degrees Celsius for my K2CR2O7, how much should I be able to dissolve in, roughly?
Like 4.
Yeah, all right. So if I have 58 grams sitting in that container, but only 4 dissolves in, what's the rest of it doing?
I don't know.
Have you ever poured way too much drink mix into the water and some of it just stays at the bottom as like a powdery sludge?
Yeah.
So that's what's happening. So you would only have basically 4 grams dissolved in. And since you had 58, you subtract out the 4 that dissolved in. God, that echo is killing me. And you'd end up with 54 grams, 58 minus 4, 54 grams of this sitting on the bottom of the drink container. Now it says we're going to stir this thing up and we want to see what temperature must the solution be raised to produce a saturated solution. So I want to get to the point on this curve where all 58 grams is dissolved. So guys, tell me what temperature I probably need to get up to roughly.
Like 80.
So Dylan says 80. Stella, what do you think about 80-ish degrees?
Yeah, I agree.
Okay, and I totally agree too. So we would have to get this up to about 80 degrees. And at that point, all of it would be dissolved in. Now, trick question, coming back to you, Dylan. Down here, when I had 58 grams, but only 4 grams dissolved in, is that unsaturated, saturated, or supersaturated?
Saturated.
Very good. Don't fall into the trap of thinking that just because you have more solute than you should, that it's a supersaturated. Supersaturated is very particular. You have to heat it up, you cool it down slowly, and you have more dissolved in than you should. That is not what you have in this problem. So very good. 1 or 2 more here, and then I think we're going to call it a day because I think you guys are doing real well with this. So as we look at number 6, saturated solution, KClO3, and now it's made with 300 grams of water at 34 degrees Celsius. So I've got a little issue here. I'm at 34 degrees on my KClO3 curve. If this was 100 grams of water, Stella, how much would we say is dissolved in if it was 100 grams of water for this?
It would be dissolved in 10 grams of water.
Okay, it would be, careful, it would be 10 grams. This is the number of grams of the salt. So it would be 10 grams of KClO3 in the 100 grams of water. Now, I've made it 3 times as much water. So what do you think we do to that number 10 that you just gave me here if it's 3 times as much water?
Multiply it by 3.
Yeah, that's all you have to do. So you're going to take the number from the graph and you're going to multiply it by 3. So to make a saturated solution, you would have 30 grams, all right? So if we have a saturated solution with 300 grams of water, and then we just evaporated all of the liquid, we would get back our 30 grams of KClO3. Last question that involves a different quantity of water. So now I've got 500 grams of water, saturated solution of KCl at 15 degrees Celsius. So here I am on my KCl at 15. Come up with an answer in your head. How many more grams of KCl could be dissolved if the temperature were raised to 78? So there's a couple things going on here. Dylan, if I didn't even worry about changing the temperature, in 500 grams of water at this temperature, how much KCl would I need to create a saturated solution?
30.
All right. I agree that 30 grams would work if it was only 100 grams of water, but it's 500 grams of water.
So 150.
Because I'd have to take that number and multiply it by 5. Stella, you okay with 150 there? Because I'd have to do it 5 times as much.
Yeah.
Okay. Now let's add in the last part, because this really gets at, and this is about as hard as it's going to get. So I'd have 150 grams of KCl. If I take this all the way up, so Dylan, I'm coming back to you. If I take this all the way up to my 78 degrees, and I'm on KCl, now the number that I'd have to have is this, but remember it was 500 grams of water. So what number would I be thinking about for 500 grams of water here?
250.
250 grams. So let's go back and look at the question. How many more grams of KCl could be dissolved? So this is what I would have had at the start. This is what I would have had at the end. So if I wanted to know how many more grams it is, what would I do here, Dylan, with these two numbers?
Subtract them.
Bingo. And so the answer would simply be whatever 250, and I'm off the screen there, minus 150 is, and that's easy math. We'd be able to dissolve in an additional 100 grams. Okay? Now, this is tricky for some students, but hopefully just the process of kind of walking through this and letting me guide you helped. The assignment is, I'm going to go ahead and stop sharing my screen. The assignment is posted on Canvas. Work on it. This took about half an hour, so I'm going to let you guys work on it tomorrow. It'll be due on, today's Tuesday, it'll be due on Thursday. Any questions from you guys?